Hi all and welcome back to a new video. So in this video we will see how to iterate through elements inside a Numpy array. So let's begin by importing the Numpy library into our code by typing import numpy as np. Okay, now let's quickly go ahead and create a Numpy array, and for that I'm going to type np dot arrange, and let's make a 15 element array starting from 0. Okay, so maybe like just give it 15, and then let us reshape this into maybe a 3 by 5 array. Okay, let's quickly copy this into a variable arr1 and run this cell and see what is inside arr1. Okay, so we have a 3 by 5 array with starting from 0 up until 14. Total we have 15 elements. Okay, cool. So what we're going to do is, in order to iterate over these elements, we can use a for loop, right? So when I run a for loop for maybe like elements in this particular array, which is arr1, what this essentially does is the elements inside this particular array is like we have like 3 elements, like 3 rows, right? So first what it is going to do is it will fetch these rows as the output. Okay, so but I want each elements as the output, right? So what we can do is, let us just print this and see what we get as output. So print elements, and let's just see, run this, and we get this as output exactly as we expected, right? Like the first element, this particular array, the second one is this, and the third one is this particular list. Fine. So in order to access each element inside these, we'll have to run a nested loop. Okay, for example, so we are going to write 4 rows inside arr1. What I want is, I want to run inside these rows. So for elements in maybe rows, right, I want you to print elements here. Fine. When I do that, what I get is rows is not defined. So sorry, we have a spelling mistake. So when I do this, we get each and every elements as the output, right? So this is one way to access each elements or iterate through each elements inside an array. So this is the case of a 2-dimensional array, right? What if we have a 1-dimensional array? For example, what if we just had only this much? I'm going to create a new array which is arr2 and just this, and run this arr2, and this is what is inside arr2. So this is now a 1-dimensional array. In order to access elements inside this, when I run a for loop for elements in arr2, print elements, right? And when I run this, I get access to every element, right? So there is this one way to flatten n-dimensional array into 1 dimension, and that is called the flatten function. For example, when I apply flatten function on this particular thing, and I'll get an array exactly same as arr2. For example, as of now arr1 is this, right? When I apply arr1 dot flatten, what I get in return is this particular thing. This is converted into a 1-dimensional array, right? And now when we apply a for loop on this, we get access to each and every elements, right? So what we can essentially do is, let's just backspace this and run this again. Now this is a 2-dimensional array. So for elements in arr1 dot flatten, I'm just going to print elements inside this, and we get the exact same output. So this is another way to access or iterate through each elements inside an array. Okay, fine. There is one more way to do the same process, that is by using the Nditem method, and the way to use it is simple. For example, I'm going to iterate through something for maybe elements, like elements in arr1, right? So instead of ARR1, what we have to do is we have to access the Nditem function first using the np and np.nditem, and inside the bracket the first parameter is the particular array that we have to iterate to. So that is, in this case it is ARR1, and let us just simply print elements and see what happens if there is any error or not. Then elements, and then run it, and we get this particular right, and that is because we have a second parameter here called the order in which this should iterate, and by default the order is given as C. Okay, so when I run this again, I get the same output, right? So what if let's see ARR1, what if I don't want to iterate through these elements in this order, like the row wise order, like 0 1 2 3 4 5 6, and instead I want column wise order, like 0 5 10, then go to this 1 6 11, then go to this, then go to the next column. What if I want that order? For that I can give instead of C, I can give F and then run it again, and I get this, like 0 5 10 1 6 11 2 7 12 3 8 13 in column wise order. Fine. So that are the two things that you have to note here. That is about accessing each elements in column wise order, right? What if I want each column to be separate output? For that I can specify this particular parameter which is called flags, and inside flags I can give a list, and inside a list I am going to specify external loop, external underscore loop, and let's see what happens. We get each column as a separate list, right? So that is what flags does, and we have one more similar parameter called op flags, and what it does is it essentially helps us to iterate through elements and then make changes to it. We can apply mathematical operations on each element, and we can change or we can alter the existing array with just providing that particular parameter and the operation to be done. So let's see how it is done. Let's quickly cancel this parameter, and then we can add the new parameter which is op underscore flags, and which is equal to, and inside the list I'm going to specify read write. Okay. When you check the documentation, you can find different things that can be given here. In this case I want to read values and alter it, so I'm going to give read write, and the syntax is quite different. Just see this. So I'm accessing each elements inside a straightened array, right? Like I'm accessing each and every element inside it, like so in first case elements take the value 0, right? Here is the ARR1, so in the first case elements will be taking 0. So what I want to do is just provide this first, like elements, and in a square bracket inside that provide 3 dots dot dot dot, see the color changes here, and equal to, and then give the operation to be done on each element. In this case I want the first element, maybe like I want to multiply each elements with some other value. So what I can do is access elements again, elements, okay, elements star, maybe like elements star 2. Okay, so the new array will contain each element multiplied by 2. So when I run this and access ARR1 again and run it, and I get a new array with each element multiplied with 2, and compare it with this, 1 has become 2 and everything is multiplied with 2. So now the original array has been altered into this, and let's see, I want maybe square of each element. What I can do is star star 2, and when I run this and run the original array again, now the square is taken from the previous array, which is like the element here was 10, right? So let's go back to the array creation, and this is our original array, right? Once more run that, and let's see what ARR now is. So now ARR this, okay, and let's run the cell again and run it again, and let's see the new values of ARR1. So now we must be getting squares of each elements in this, and when I run this, I get square for each element, like 5 square 25, 10 square 10, 6 square 36, etc. Okay, so you can check the documentation and play with these parameters again. That's all for this video. We'll see you in the next video. So bye bye.